Welcome to the deep dive. Today we're looking into something pretty fascinating, a potential link between the health of our eyes and our risk for schizophrenia.
That's right. We've got this interesting new study out of Zurich from the university and the University Hospital of Psychiatry.
Yeah, we're diving into the details from those Eingefügter text excerpts you sent over. So the big question, I guess, is, can looking at the eye really tell us something about brain health, specifically about schizophrenia risk?
Exactly. And the really exciting part is the potential for, maybe spotting risk much earlier than we currently can.
It sounds almost too simple, doesn't it? Looking at the eyes to gauge risk for something as complex as schizophrenia. How? How does that connection even work anatomically?
Well, it's pretty unique, actually. The retina, the layer at the back of your eye, it's not just tissue that senses light. It's technically part of your central nervous system.
Ah, okay, like a direct extension of the brain.
Precisely. So the thinking is, if there are changes happening in the brain, perhaps related to schizophrenia risk or development, maybe, just maybe, those changes could be mirrored in some way in the structure of the retina.
Okay, that makes a bit more sense. Now, I know there's been some earlier research floating around, things about reduced gray matter in the brain, maybe even hints about thinner retinas in people already diagnosed with schizophrenia.
Yes. But those studies often left us wondering, was it the condition causing the changes, or maybe the medications people were taking, or lifestyle factors? It was hard to untangle cause and effect.
Right. So what makes this new Zurich study different then?
The scale and the approach, mainly. They tapped into the UK Biobank, a huge resource with data from, hundreds of thousands of healthy individuals.
Healthy individuals, okay. That's key.
Yes, and for these healthy people, they calculated what's called a polygenic risk score for schizophrenia.
Polygenic. So not one single gene, but like a combination of many different genetic variations that together might slightly increase someone's susceptibility.
Exactly that. It's an estimate of overall genetic loading. And then they looked to see if this genetic risk score correlated with any physical measures, including retinal thickness.
Did it?
It did. They found that among these healthy people, those with a higher polygenic risk score for schizophrenia tended to have, on average, slightly thinner retinas.
Slightly thinner. So we're talking subtle differences.
Very subtle. You probably wouldn't see it in one individual, but across such a massive data set, the pattern emerged as statistically significant.
Okay, interesting. But why focus on the retina? What's the advantage there compared to, say, looking directly at the brain with an MRI?
Practicality and accessibility. Measuring retinal thickness is relatively easy, cheap, and non-invasive. It uses a technique called optical coherence tomography, OCT.
OCT. What's that?
Think of it almost like an ultrasound, but using light. An ultrasound for the eye. It takes just a few minutes, gives incredibly precise measurements of the retinal layers. Much simpler than getting a detailed brain scan.
Okay, yeah, I can see the appeal. Faster, cheaper, easier.
Yeah.
So this opens up possibilities for, what, earlier screening maybe?
That's the hope. If these findings hold up in further studies, especially longitudinal ones that follow people over time, OCT could potentially become a tool for identifying individuals at higher genetic risk before any symptoms manifest. Early detection could lead to preventative strategies, but, we need more research to confirm that.
Makes sense. So thinner retinas linked to higher genetic risk. What about the inflammation angle mentioned in the study? How does that fit in?
Right, that was another really interesting piece. They found that some of the genetic variants linked to both schizophrenia risk and thinner retinas were also genes known to be involved in inflammatory processes, particularly in the brain.
So suggesting inflammation might be part of the mechanism, connecting the genetic risk to the physical changes in the eye and potentially the brain.
That's the hypothesis it strengthens, yes. It adds weight to the idea that neuroinflammation might play a role in how schizophrenia develops or progresses, and that these retinal changes could be a reflection of that process.
And if inflammation is a key player, does that suggest potential new treatment avenues down the line?
It certainly opens that door. I mean, if inflammation is confirmed to be centrally involved, perhaps future therapies could target those inflammatory pathways. It's speculative at this stage, of course, but it offers a potential new therapeutic angle to explore.
Okay, so let's wrap this up. The key takeaway from this deep dive seems to be that our genetic predisposition for schizophrenia might leave subtle but measurable traces in the structure of our retinas.
Exactly. And it gives us this potential non-invasive window using OCT to maybe identify risk earlier. It really highlights how interconnected the body is and the power of using large data sets to find these sometimes unexpected links.
It really does. It makes you think, doesn't it? What other physical characteristics, maybe things we see every day, might actually hold clues about our underlying health or predispositions? Where else might we find these accessible windows into our own biology, especially the brain? It's a fascinating look at where preventative and maybe more personalized medicine could go. Thanks for breaking that down.